Good evening, students. Today let us understand the concept of the previous concept, actually the velocity and acceleration from the graphs. Got? So means average velocity and your instantaneous velocity, average acceleration and instantaneous acceleration, we will know it from your graph. Got? So like we can say here simply, I will be using the symbol A for acceleration, V for velocity, bar means average, and simply A and V means your instantaneous acceleration, instantaneous velocity, average acceleration and average velocity. So let us write down the formulas first. You know, the average velocity V bar is given by x2 minus x1 by t2 minus t1, which is simply del x by del t. And your instantaneous velocity is what? It is limit delta t tends to 0, this del x upon del t, which is dx by dt. Now comes to your acceleration. Your average acceleration is what? In the same form, it is v2 minus v1 by t2 minus t1, which is del v upon del t. And instantaneous acceleration is given by limit delta t tends to 0 del v upon del t, which is equal to dv by dt. So let me tell you, here x is what? X is what? Your position, change in position with respect to time. And the value is instantaneous, means if the value of your instantaneous velocity tells you this, if this time span tends to 0. In the same case here, if the time span tends to 0 means the quantity involved here, it is your instantaneous quantity. And let me explain you, this instantaneous velocity is what? It is the derivative of your displacement with respect to time, and the acceleration here, it is the derivative of your velocity with respect to time. What? So if you know the x means position as a function of time, if you know this function, then from there only you can find the average value of your velocity, instantaneous value of your velocity, average value of your acceleration and instantaneous value of your acceleration. That you can know if you know this function. Got? Why? Because velocity is a derivative of your displacement and acceleration is the derivative of your velocity. Suppose you have given a function x versus ft. So from that graph you are going to find out these two quantities, velocity, because they are directly, velocity is directly linked to this your position or displacement. So let us understand the concept of your average velocity. Average velocity, suppose you found the graph between x and t is like this, and you are asked to find out the average velocity by using this formula. You are going to explain average velocity from graph. So you take two different time instances, t1 and t2. Let's say this is the time instant. Yes, so you draw perpendicular from here to here. Let's say 2 points on the graph, A and B. Here it is A and here it is B. For A, the time here it is t1, and for B, the time here it is t2. And for A, the corresponding position is x1, and for B, the corresponding position is x2. Now from the graph, the average value represented means you join this line AB, you draw a perpendicular here in this line BT2, so that they will meet here. This angle is 90 degree. Let us mark this point to be C. That quantity del x by del t is what? This del x by del t is your average velocity. Del x means is your VC. Del x is what? It is x2 minus x1, means this length. This length BC is your x2 minus x1. and your AC is your T2 minus T1, which means delta T. So here I can write your del X by del T is what? BC upon AC. So which is BC by AC. So if this angle would have been theta, then BC upon AC will be your tan theta from the graph. So the meaning of your average velocity is this much. You can know it from the graph if the function of x versus t is given. In the same way, we can explain the value of your average acceleration provided the velocity as a function of time must be given to us. Got? Else, if x as a function of time would have been given to you, you find the function for your velocity by using this function v is equal to dx by dt. So you can get a function of velocity, then only you can plot a graph between v versus time. Just like what I have done here, to know the instantaneous velocity I have plotted x versus t graph. So similarly, to know the average acceleration here or instantaneous acceleration here, you need to take v versus t graph. If this graph would have been v versus t graph, this value would have been your average acceleration. Now let us find out the instantaneous velocity in the same graph. Instantaneous velocity, suppose you plotted the same graph again, x versus t, and you found your graph would be like this. V is equal to dx by dt. In your previous classes of derivative, I have already told you what is dx by dt. Dx by dt is what? Nothing but the slope of a graph at a particular point. The slope of the tangent means it is nothing but the slope of a tangent at a particular point to the graph. That is called your dx derivative. So similarly, here x versus t graph is given. So means the derivative of x with respect to time. Means if x and t graph you plot, so at a particular point if someone will ask you, let's say at this time, at this instant t1 or t dash, what is the value of the velocity? Then what you need to do, exactly at that point you draw a tangent to the curve. Yes, the tangent to the curve is making some angle with your time axis, let's say alpha. Simply you find tan alpha. This tan alpha will give you your instantaneous value of the velocity. See, this is nothing a new concept. It is the concept of your mathematics, what I have already explained in your derivative. Got? Try to understand here why it is called instantaneous. In this case, actually we are finding t2 minus t1, but the t2 minus t1, t2 corresponds to your point B here, t1 corresponds to the time coordinates of point A. If they are very closer, means if A and B they are very close together, then that straight line AB will appear to be a point here. And if you extend that line, it will be the tangent at that particular point. So this formula we are applying here, but at that condition t2 minus t1 is neglected, and which is tends to 0. On that condition we are finding the value of your delta x by del t, and that gives your instantaneous velocity. So if you draw a tangent at a particular point to a graph, yes, and a tangent is making some angle with your time axis, let's say that is alpha, find the tan alpha of this, then that value will give you the instantaneous value of the velocity. Similarly, if you replace xt with v and t, if you replace this x and t with v and t, you are going to get the value of your acceleration. The concept is simple. Got? Now the important point here, suppose x as a function of time is given to you, and you are asked to calculate velocity and acceleration. From x, if you find the derivative of x, you can find the velocity's function, and from v, if you can find the derivative, you are going to find the acceleration function. So if you are clear about the concept of integration, we know integration and derivative, they are just the inverse of each other, two inverse mathematical operations. If you know it clearly, then if you go in the backward direction, suppose the function of acceleration is given to you, the acceleration as a function of time given to you, then how you can find the value of your velocity or the function of the velocity? Like, let us understand here, we know A is equal to dv upon dt. So which implies dv is what? It is simply A dt. So if the function of A would have been given, means you, from this equation you integrate, as if you integrate dv and integrate E dt. So if you integrate this quantity dv, you are going to get velocity, and which is nothing but A dt's integration. Simple logic here, as the derivative and integration, they are the inverse of each other. It means if A is the derivative of velocity, then velocity must be the integration of your acceleration's function. The simple logic, according to our logic we have just applied. Similarly, in this case, I can write that case, in that case here, if velocity is the derivative of displacement, then displacement is nothing but the integration of your velocity function. We can find, if you take a proper time limit, you can find the value of your positions, and that you can get that functions. But so basically, let me summarize it. If you know the function of your position or displacement, you can find the velocity by finding dx by dt. So you will get it again, the velocity as a function of time you can find, and you can get the acceleration by finding the derivative of your velocity's function. Got? So from here to here, if someone has given the function of position, from there if you find the derivative, you are going to get the velocity. If velocity's function is given, if you find the derivative, you are going to reaching here by finding the acceleration. If acceleration is given, then you can reach to your velocity. V is equal to integration of A dt. Got? So means in the backward direction, if you come from this direction, you can use your derivative formula. If you go from acceleration to in that direction, you need to use your integration. Means from this equation, if you want to find out the value of your position, it is nothing but the integration of your V dt. With the proper limit you can take and you can find out the value. So this is the most important point, students. So some questions may be there, but it is a higher concept, you just keep in your mind. It is nothing but a mathematical just formulation. Means integration and derivative, if you are acquainted with, then this thing will be very clear to you. Students, let us solve a question here. Previously already I have solved questions if the function of x is given to you and you are asked to calculate the value of v and you are asked to calculate the value of acceleration in my previous videos. Now the reverse thing, let us find out here. Suppose there is a question, here it is given the function of acceleration with a time like this, a is equal to 3t square plus 2t plus 2 meter per second square, where the unit of acceleration is meter per second square and unit of time is second. This is the question. And the data given, v is equal to 2 meter per second square when time was 0, means t is equal to 0, v is equal to 2 meter per second. This, when t is equal to 0, v is equal to 2 meter per second, means it is given your initial velocity. The question asked, find the velocity at t is equal to 2 seconds. But we know the simple formula, v is equal to, we know simple formula, a is equal to dv by dt. Then dv is equal to a dt or if you integrate both the sides, now we can use this formula because the function of acceleration is given. If the function of velocity would have been given, then you can find the derivative of velocity to find out the acceleration. But here what is given? Acceleration is given and you are asked to calculate the velocity. And we can write here, so when t is equal to 0, your v is equal to 2 meter per second. Means this is the initial value. And you need to find out v when t is equal to 2, then v is equal to, let us take it to be v dash. I need to find out. So in this case the limits is given. You see, left side is a function of velocity, right side is a function of your time. So the limits is we need to find out from the question itself. The time starts from 0, so as it is a function of times in the right side, so we put time to be 0 in here and it ends at 2 seconds. And for the velocity, initial velocity is 2 meter per second, so you can take it to be 2 here, and your final velocity is v dash, that you need to find out. So now let us integrate and put the function of acceleration here. So if you integrate the left side, which implies I can write integration of dv is what? Which is your v, and the limit is 2 to v dash, which is equal to integration of 0 to 2, acceleration is how much? Put that function 3t square plus 2t plus 2 into dt. This is nothing but I am just applying that function of your acceleration here, as acceleration is a function of time. Now let us apply the formula of your integration. Three functions are added together, so you need to integrate them separately. Integration 0 to 2 3t square dt plus integration 0 to 2 2t dt plus integration 0 to 2 dt. This is the formula of your definite integration, because limits are given. Now your left side becomes this, I can write. So I apply the formula for your definite integral. Instead of this v, you can put the upper limit v dash minus the lower limit 2. So which implies this equation represents v dash minus 2 is equal to this thing. So now you need to find out this integral. So which implies v dash minus 2 will give you 3 is a constant, you take it outside. Integration of 0 to 2, the integration will be t square, or you can simply write another step 0 to 2 t square dt plus here 2 is a constant, take it outside 2, integration of 0 to 2 t dt plus again 2 is a constant, you take it outside 0 to 2 dt. Now let us solve this question here. Right in this here, which implies v dash minus 2, it will be 3 power of here t is your 2. So I have applied the formula, this formula, integration of x to the power n dx, x to the power n plus 1 by n plus 1. This formula will be applicable here. So t square 0 to 2 dt, it will be that formula, x to the power n plus 1 means t to the power, here this power is 2 plus 1 by 2 plus 1. So t cube by 3, and the limit will be 0 to 2 plus the second term similarly 2, the power is 1, so it will be 2 into t to the power 1 plus 1 means 2 by 1 plus 1 means 2, and the limit would be 0 to 2. And the third term, 2 is a constant, and integration of dt simply t. So plus 2 is a constant, and integration of dt will be your t, the limit will be from 0 to 2. Now let us solve it, which implies V dash minus 2 would be 3 into, and you see here it is 3, here it is 3, so it will got cancelled. Here 2 got cancelled. Means it will be t cube. So t cube limit 0 to 2. So means instead of this t you put the upper limit. Means 2 to the power 3 minus, again instead of this t you put the lower limit 0 to the power 3, the first term, plus the second term would be t to t square, means upper limit square minus lower limit square, plus here it is 2 whole into upper limit minus lower limit. Now I can find the value, which implies V dash minus 2 would be 2 to the power 3, which is 8, plus 2 square means 4, plus this is 2 minus 0, which is 2, 2 into 2, 4. So which should be 4, 4, 8 plus 8, 16. So which implies V dash is equal to 16 plus 2, because this minus 2 will take the other side, become positive, so which is 18 meter per second will be your answer. So this is the answer. In this way you need to approach the question. Thank you.